But again, your book handles it this way, so log of left-hand side equals log of right-hand side. So left-hand side is 4 to the x, right-hand side is 5 to the x minus 5, and I remind myself there's a set of parentheses around that x minus 5. Bring the exponents down, so that's how you get your grubby hands on x. So log of 4, x minus 5, log of 5. Now what do? I can't necessarily, well, I could, but it still wouldn't be fun. Divide log of 4 divided by log of 5. I could do that, but notice the x is in parentheses. I don't have a choice. I've got to remove those stinking parentheses. At this point in time, especially in this class, if you wanted to switch over to decimal notation, log of 4 is approximately 0.6. And then log of 5 is approximately 0.7. And you can work the problem that way. So in other words, I'd be looking at this, 0.6x equals 0.7 times x minus 5. That's going to make your life a lot easier. If you want to kick it out to more decimal places, you can. But when you got an ugly problem, sometimes that's what you need to do. However, I'm going to work it through. What would I need to do? First thing, clear parentheses. X log of 5 minus 5 log of 5. Now what's what we always do? We bring everything to the same side that's got x's in it, and anything that doesn't have an x, you leave on the other side. So x log of 4 minus x log of 5 equals minus 5 log of 5. Now what did you notice on the right-hand side? No. What else do you notice? I'm sorry, on the left-hand side. I'm sorry. On the left-hand side, what do you notice? Because I'm trying to solve for x. What does it have? They both have x's, right? So I have a GCF of x. This is the trick, by the way. So I can call this the trick. You'll run into this many times in college algebra. Factor out GCF of x. So that's a trick. So log of 4, log of 5 are numbers. So now I just divide both sides by log of 4 minus log of 5. So that reduces out. So x is going to be minus 5 log of 5 divided by log of 4 minus log of 5. And do I have, yes, no I don't know. Do I have an approximation for that? Yes, I do. It's approximately 36.06. Ugly. I know.
Did you do the bottom first and then?
No, yes, well.
Because if you do it all together,
Well, if you're going to try to do it all together,
I probably should just do
So it would be -5 log of 5. Now, I have to make sure that's okay, and that's fine. It's the denominator that's the problem. So you have to put the denominator in parentheses, and that's log 4 minus log 5. So log of 4 minus log of 5.
I didn't put it in.
See, and what you could do is you could take the numerator, get a number, take the denominator, get a number, and then divide. It's hard because that denominator is more than one term. Now, in dealing with E, we need to remember some things. Is that we can use the natural log in E, and you're going to say, well, why is that? We want to remember that ln of E is 1, and that's because log base E of E is 1. So if I follow it through, anytime I'm dealing with E, I use natural log. So if I had e to the 1.2x equals 78, I take the natural log of both sides instead of taking the regular log, bring the exponent down in front. So I have 1.2x natural log of e is the natural log of 78. Natural log of e is 1. So 1.2x is equal to the natural log of 78. So that x is the natural log of 78 divided by 1.2. Again, this is an exact answer. And then I calculated it out and rounded, that's approximate. You're going to be dealing most of the time with e and natural log. So if I had e to the 2x is equal to 7, it's e, so I'm going to use the natural log of both sides instead of the log. This is e to the 2x and 7. Bring the exponent down in front. 2x natural log of e is the natural log of 7. We said natural log of e is 1. So 2x equals the natural log of 7, or x equals the natural log of 7 all over 2. And that's an approximation of 0.973.
I have a question. On the problem before, if we choose to do the decimal, it's fine that it's a little bit off.
It's going to be a little bit off, yeah. That's because of rounding.